Okay, I hope the sound is now better. This is question 3. Okay, here we've got to find dx by dy, which is a bit odd, I agree. It's a bit unusual, but it's the same really. Okay, so x is equal to tan 3y plus 1, so dx by dy is equal, I'll leave a gap here, is equal to sec squared 3y plus 1. That's in the formula book. The differential of this is 3, so the 3 goes in front. So that's the answer in terms of y. Find the value of dy by dx when y is a third. Notice they want dy by dx, and we've got dx by dy. So over here, dy by dx will equal 1 over 3 sec squared 3y plus 1. I don't know why that disappeared, over 1, which is 1/3. Now the sec squared can go up top to give us cos squared 3y plus 1 when y equals minus a third. Dy by dx will equal a third of cos squared. Now 3y will be minus 1, so that's 0. And we should know what the cosine curve looks like. Cosine curve goes up like that, so at 0 it's worth 1, so it's 1 squared, so that is a third. So the question was, find the value of dy by dx is that. Now we've got to sketch the graph. Of that. Now this is requires a bit of thought. Now the normal tangent graph has a sinusoid here, which goes up there like that, where this is 90 degrees. Okay. Now the other thing to remember, that's not very good, let's draw that again. So it goes up like that. Now if I draw the line y equals x, which is something like that, the inverse function goes that way, something like that, and it will go towards 1.53. So basically the best answer is this, coming up like this and going like that, where this line here, which I can't pronounce, is roughly 1.57. We said 90 degrees, or we could have said pi over 2. Pi over 2, which is roughly 1.57. Then it goes this way around like that, where this line here will be minus 1.57, but it's only a sketch. That was 3a. That's finished question 3, I think. There's the question. Okay, pause. Question 4. The functions f and g are defined with their respective domains. Okay, and the question is, find the range of f. Right, now the normal cos curve, y is equal to cos x, is obviously like this. Okay, y equals 3 cos x is pretty much the same, but it's just a different scale. Okay, so it goes down like that and like that. Now in this case this is 1 and this is minus 1. When it's a 3 in front, this becomes a 3 and this becomes a minus 3. Now the x over the 2 has the effect of just doing the first part of the graph, so it looks like this. So it looks like that. where this will be 3 and this will be minus 3. I hope I've got that right. Let's pause that and see. Pause. Yeah, so that's okay, except this will be 2 pi here. So my drawing's a bit, it should be fatter, as it were. If you look at here, you can see the okay, so the red is the normal cosine curve, and that's with the half. Okay, find the inverse of f. Okay, so first of all I'm going to say let y is equal to 3 cos x over 2. Interchange. Now some people do this at the end, I do it at the beginning. Interchange x and y. So we get that x is equal to 3 cos y over 2, or x over 3 is equal to cos y over 2. Now if we do the inverse of that, we shall get cos minus 1 x over 3 is equal to y over 2. We really want it y equals, so in fact y will equal 2 cos minus 1 x over 3. So we normally write it as f minus 1x is equal to 2 cos minus 1 x over 3. Okay. We found the inverse. Solve the equation, that equals 1. Okay. Right, let's clear that off. So the inverse function equals 1. So 2 cos minus 1 x over 3 equals 1. So cos minus 1 x over 3 equals a half. So x over 3 is equal to cos of a half, which means x is equal to 3 cos a half, which is the answer. Okay. Write down the expression. Okay, right. I forgot what gx is. Okay. We want g of fx. Okay. So we want g of fx. That means we put fx into g. So we have vertical line 3 cos x over 2. Write down the expression for that. We've done. That's correct. Sketch the graph of that. Okay, so we want this graph. So y is equal to 3 cos x over 2. And wait a minute, did I do that right? Yes, that's correct. Okay. Now, we've already done the graph of y equals 3 cos x over 2. which was, this is 2 pi, remember, 2 pi, so the graph comes down like that, as it were. Now, that's that graph there. The effect of the absolute values is to make it come up like that. So the answer is down like that to actually pi, and then up again to 2 pi. So that's the answer there. Describe a sequence of geometrical transformations to map cos x to that one there. Okay. Well, y equals cos x is that, y equals 3 cos a half x is going to be 3 times taller, so it's a stretch or 3 times, stretch times by 3 vertical axis, or on the y-axis, on the y-axis, and then it's a stretch by 2, stretch by 2 on the x-axis. So that's spelling there, stretch T. Okay, that's for D. That's finished number 4.